Hello, my friends. In this video, we'll be taking a look at the autosomal DNA results, predicted phenotype traits, and G25 results of a Iron Age sample from northeast of France, from this region right here, Grand Est in France. This sample lived in the Iron Age, and this is a Gaulish Celtic sample. Celts, at a certain period in time, inhabited a very large portion of Europe, much larger than just France, Spain, Portugal, Britain, Ireland, Germany, but even places in Ukraine, like Serbia, Romania, Turkey. Celts lived pretty much everywhere at some point. But from what I know, in the Iron Age, they also lived in France. And nowadays, people in France don't really speak Celtic languages. There is people in, I think, Brittany who still, some of them still speak Celtic languages. I think there's Brittonic or something like that, that still speaks Celtic languages. Uh, Correct me if I'm wrong. I might be wrong, but I think Brittonic is a Celtic language. Um, but people in France nowadays speak a Latin Romance language that ultimately derives from Latin. Even though the genetics of French people are mostly very Celtic. French people are kind of like they're kind of like Celts who speak a language from Italy. So they are still very Celtic genetically, but they are speaking a language that came from Italy. So this sample is kind of like ancestral to French people. This sample is very French with G25. If you look at what it scores with G25, it's very similar to French, Belgians, which are pretty much like French but in a different country. Belgians and French are very similar genetically. French Alsace, French Paris. So this sample is very similar to modern day French people from this same region. There is very little differences. Actually, if you compare Celtic samples from French versus French people today, there is so few differences. French people haven't really changed all that much from the Iron Age until now. And further down, you see samples such as Basque, and then you see Germans, but the proximity to Basques is very interesting. So this sample is quite Mediterranean, actually. This sample is quite, even though it's northwestern European, this sample has some proximity to Mediterranean populations, such as the Basques and Spanish. And if you look at three-way admixtures, it can be modeled as a mixture of 70% Basque, 15% Latvian, and 13.8% Finnish East. So relative to the Basques, this sample is actually a little bit has an admixture from northeastern Europe, which makes sense because Basques are so heavily on the European farmer and Western hunter-gatherer component that the heavily steppe, heavily Eastern hunter-gatherer component of Eastern Europeans, you need to have that heavily steppe and heavily Eastern hunter-gatherer component of Latvians and Finnish to sort of um, negate that farmer component in Basques. So it makes sense that the model is like that. I think if we do add distance column 0.5, it would be a little bit different. No, it's still the same. What about 1? It's going to be different now. Okay, now it's different. Now it's Basque, Spanish, and Ingrian. So it's still kind of more of the same. It's very surprising that the model is like that. So it looks like the best mixture, the best admixture model for this sample is some kind of a mixture of Southwest European and like extreme Far Eastern European, such as Latvian, Finnish, or Ingrian. In case you don't know what Ingrian is, because I'm assuming that everybody knows what Basque and Spanish is, but in case you don't know what Ingrian is like ethnicity that is indigenous to this area right here in Leningradskaya Oblast in Russia. It's a Finno-Ugric ethnicity that's indigenous to Leningradskaya Oblast. So this sample seems to be a mixture of Southwest European plus some kind of extreme Northeast. But that's kind of what direction-wise, that's kind of what typical Western European would score. There is not that much different. But it's just surprising that the model is seemingly picking this kind of an extreme admixture for this sample. I'm not sure why that happens. Maybe it's because this sample has a little bit of Uralic or like East Asian type of admixture that it's picking out Finnish, East, and Ingrian for the admixture model. That's very interesting. But we are going to move on to the samples and results with Nashakot. And alright, so with Nashakot, this sample is scoring brown eye color at 82.6% likelihood. So this sample has got brown eyes. Looks like hazel eyes are only 10.7% odds, and dark brown eyes are 6.2% odds. So most likely the sample has got regular brown eyes, not necessarily dark brown, not necessarily hazel eyes, and definitely not green or blue with amber or blue. For hair color likelihood distribution, most likely the sample has dark brown hair. Black hair is also possible at 20.6% odds, but most likely the sample has got dark brown hair. And for skin color, most likely this sample has got olive or Mediterranean skin, although light brown skin is also quite possible. So in terms of pigmentation, this sample is kind of like a typical French person, right? Olive or Mediterranean skin, dark brown hair, and brown eyes, very much a typical French phenotype. It could also be a very typical phenotype for a Syrian or a Afghan or a who else? Spanish, Greek, Turk. I mean, from France to Syria, they all kind of look very similar, right? It's all kind of the same Mediterranean, one grand Mediterranean race. They all look very, very similar to each other. But he does look French. I mean, he looks French, and he's got looks like curly, wavy, or straight hair, but most likely curly or wavy. And for nose shape prediction, he has a prediction for snub or Greek shaped nose. Looks like more or less intermediate nose shape prediction. Even prediction for snub and Greek shaped nose. Now for coloring related variants found in the file, looks like heterozygous gene type in this variation of HERC2. So with snipper 3, we are not going to see blue eyes for sure. And no BH2, no BH3, no BH1. So yeah, he definitely is going to score brown with snipper 3 for eye color. He does have heterozygous gene type in blue eye haplotype 4, which is very surprising, kind of rare. Definitely a very rare genotype. He also has this genotype in this variation of OCA2, which is kind of surprising. So definitely quite an interesting genotype. Typically, light color variants in this variation of OCA2 go together with light color variants here and here. So it's surprising that he doesn't have these linkages together, but it's whatever. He does have two light color variants in SLC24A5 and SLC45A2, so there is some predisposition to lighter pigmentation of eyes, hair, and skin. He's a typical European. The genotype in SLC24A5 and 45A2 is a typical European genotype. He also has two light color variants in this variation of IRF4, which is very surprising actually, and this does contribute to lighter pigmentation of eyes, hair, and skin. But without having any of the blue eye haplotypes, it is impossible to score lighter eyes, hair, and skin. So this genotype is not enough for him to score lighter eyes, hair, and skin, unfortunately. For MC1R, he does also have one variation for pigmentation for ginger hair color. But once again, with this kind of a genotype in blue eye haplotype, in all the blue eye haplotypes, not having any of the blue eye haplotypes, you are not going to score ginger hair with this type of genotype in HERC2. So having this one variant for red hair in MC1R, it's not enough for him to score red hair. I think he does score more red hair than blonde if we compare. Yeah, he does score much more for red hair than for blonde. 0.43 versus 0.0 or 0.008. So he does score much more for red hair than he does for blonde, but it is still less than 1% for red hair. And I'm not even going to look at the snipper 3 phenotypes because there is no point. We already know what it's going to look like. So let's close that. Let's look at the phenotype oracle. That might be interesting. And the phenotype oracle looks like this. So all of these are sort of Mediterranean phenotypes that he scores closest to. By the way, this sample was suggested to me by somebody. Somebody sent me a list of samples and a donation. And this is an example to all of you guys. If you want me to cover some sample or you have a list of samples that you want me to cover, send me a donation and the list of samples you want me to cover, and I'm going to pick out a sample that has the highest quality, highest coverage, and I'll cover those for you, right? If it's a donation, it gives me more incentive to cover these samples for you. So there you go. I'm covering these Celtic samples from this person who sent me a donation and a list of these samples. And I'm covering the highest quality samples from this list. So the closest phenotypes looks like Mediterranean phenotypes. And the two-way admixture models show looks like a mixture of dark plus dark, and I mean, I guess this thing on the bottom, the corded Nordic phenotype on the bottom, is not very dark. It's it's really just like a typical European phenotype, but it has hazel eye color or amber, maybe it's amber, and light brown hair. So it's not really dark, but the phenotypes on top, it looks like this phenotype is dark. This phenotype is super dark. All these phenotypes are dark on top. So this result with a two-way admixture model, this sample is quite dark by European standards, and I'm seeing a lot of like exotic-looking phenotypes in the oracle. I wonder why that is. South Asians show up here. 1, 2. There's this, which is really ambiguous racially. This, which is kind of Mediterranean, but also kind of ambiguous racially. Let's look at the facial morphology oracle and see what's up here. So there is a lot of a Northeast European. There is a lot of Northeast European. This I think is I'm not sure. Is it Middle Eastern? No, this is not Middle Eastern. This is Middle Eastern, and this is Northwest European. So mostly Northwest European and Northeast European that they score for facial morphology. Yeah, interesting. And a little bit of South Asian. So they actually don't score that much South Asian. So they only score 3% South Asian for facial morphology. So the only reason the South Asian even shows up for the oracle, I just realized why it shows up. The only reason the South Asian even shows up is because the sample is so dark and because they have a specific score for nose shape and hair texture. That's the only reason the South Asian even shows up. So it's not because of the facial morphology oracle. All right, now let's look at the biomarkers results. And for the biomarkers results, the samples got very low levels of vitamin D. Let's look that up. Whenever it's super low or super high like that, it's interesting to look that up. So this samples got, looks like 3 genotypes for lower levels of vitamin D, but also 1 genotype for increased levels of vitamin D, which is very interesting. But I think this one doesn't contribute to the result in vitamin D panel for the, yeah. All right. So it's got higher levels of LDL cholesterol and genotype for lower levels of HDL cholesterol. So that's bad. Having higher LDL and lower HDL cholesterol, that's a really bad combination. You want to have the reverse. You want to have lower LDL and higher HDL cholesterol, because LDL is the cholesterol that causes blood clots, and HDL is the cholesterol that gets rid of LDL cholesterol. So ideally, you want to have the reverse of that, but that's whatever. He's got. Oh, I missed the most important. I missed one of the more important parts of the video. I just realized this. So I missed the part of the video where I talk about the haplogroup. So let's talk about the haplogroup right now. His haplogroup is R1b L51, a very common lineage for people in Northwest Europe and West Europe in general, Spain, Portugal, Italy, also Scandinavia, Germany, France, Britain, Ireland. And his mitochondrial lineage is J2B1. So that's his mitochondrial and Y DNA. All right. Now we can return back to the video. I'm sorry, I should have covered that in the beginning, but I just kind of forgot about it. Now for glucose, he's got a above average level of glucose. There's so much topics for me to cover. I just get lost in the topics, and I guess I misremembered to cover some of them. So he's got a higher level of glucose, which is unfortunate. It is also bad. A higher level of hemoglobin, which is also bad. A higher level of blood pressure, which is also bad, also quite unfortunate. And below average level of iron in the blood, so he does not have hemochromatosis. And below average level of sex hormone binding globulin, which is good. Below average level of red blood cell count in blood, and below average level of base pairs. So below average predisposition to lifespan, which is unfortunate. Also above average height, slightly above average, only 7/10 of a millimeter, so slightly, very, very slightly above average height. So there is very little difference between this and the average. All right, now let's cover the polygenic risk scores, and we're only going to look at the stuff that is way below or above the average. So he's got a way above the average odds of kidney stones, a above average odds of arrhythmia nodosum, a below average odds of hemoglobin E disease, a very below average odds of migraine, a high odds of lupus, a below average odds of gout, a low odds of thyroid cancer, a low odds of eczema, a high odds of exfoliation glaucoma. Let's look that up actually. That's very interesting. Let's look that up. So he's got this genotype which is to 10 times higher odds of. It's obviously not 10 times higher. I account for that because you have to account for the genotype frequency in populations, but it is a much higher odds of exfoliation glaucoma. All right. Let's look at everything else. He's got a average odds of polycystic ovary syndrome, a below average odds of cataracts, a low odds for age-related macular degeneration, a high odds for rheumatoid arthritis, so very high odds for RA, which is very interesting, a below average odds for Tourette's, a below average odds for epilepsy, a average odds for asthma, a high odds for leukemia, which is quite interesting, a higher than average odds for vitiligo, a higher than average odds for myopia, a higher than average odds for corneal astigmatism, a below average odds for primary biliary cirrhosis, a below average odds for stroke, a higher than average odds for male pattern hair loss, which is not surprising because West Eurasians, Europeans, people of Middle East, North Africa, and even South Asia in general will score higher for male pattern hair loss panel. People of West Eurasian descent generally are more predisposed to male pattern hair loss. So it's not surprising this individual is a little bit predisposed to losing their hair at an earlier age. He's got a below average predisposition to atrial fibrillation, below average predisposition to deep vein thrombosis, but that is based on one S&P, so it's not very reliable, and a above average predisposition to cardiovascular issues, which is very interesting. A below average predisposition to ADHD, a below average predisposition to unipolar depression, which is really good, a above average predisposition to bipolar type 1, a above average predisposition to schizophrenia, an above average predisposition to type 2 diabetes, an above average predisposition to type 1 diabetes, a below average predisposition to Alzheimer's, and a below average predisposition to multiple sclerosis. So what is concerning about this result? The most concerning issue, I would say, is the rheumatoid arthritis risk score. The rheumatoid arthritis score is probably the most interesting score in this result, but also the risk scores for type 1 and type 2 diabetes are quite concerning as well. Besides that, I don't see anything else that's at all concerning in this result. Let's go over the everything else that's here. So for breast cancer, he's got 5 out of 12 risk variants for breast cancer, which is not that concerning because none of these are important. For testicular cancer, he's got average risk score for that, average for glioma, and 13 out of 20 risk variants for testicular cancer. And he's got all the risk variants in the Ketal G variants. So for Ketal G, that's quite a dangerous genotype to have, but most West Eurasians, most Europeans have the same type of genotype in Ketal G. So his genotype in Ketal G is, although it is dangerous and although it is very much a risk haplotype for having all the risk variants in Ketal G, and in fact being homozygous for all the risk variants in Ketal G, this type of genotype is very common in Europe and Middle East and North Africa. I'm not sure about North Africa, but actually, but from my experience with samples from Europe, I know it's very common in Europe, and I know it's very common even in Eurasia in general. It is not that big of a deal because most people have it. Most people have the same type. Most people in Europe have the same exact genotype right here, and most people in Europe do not have testicular cancer. So, take from that what you will, but having this risk haplotype in Ketal G is very common for Europeans. Yes, it does lead to an significantly increased risk of testicular cancer. And it is no surprise to anybody that Europeans are much more likely than other ethnicities to experience testicular cancer. But not every European gets testicular cancer. Most Europeans never experience this disease. It's still a very rare condition to experience. So, it's not that big of a deal at the end of the day. He's got 1 risk variant for celiac disease out of 10, which is pretty good. And no risk variants for GSS, 5 risk variants for Crohn's out of 22. None of them are marked as important, so that's pretty good. No Riefenstein's, no Parkinson's. It does have some risk variants for Gilbert syndrome. All right. No basal cell carcinoma, no porphyria. I don't see anything else here. Allergies 7 out of 14, which is kind of high. So there is some predisposition to allergies here, but I don't see anything else. All right. So far, the only things we see in this file that are even a bit concerning is the risk score for type 1 and type 2 diabetes and the risk score for rheumatoid arthritis. Maybe the risk score for leukemia as well, because for leukemia you have to consider not only the polygenic risk score, but also what's typical to score for that, because it is much more um, for leukemia, the score is usually much more close to 1. Typically, the way it's coded, it's typically much more close to 1. So scoring 1.3, 1.36 is much more dangerous for leukemia than 1.36 for like myopia or something like that, or for rheumatoid arthritis. So leukemia score here is actually quite interesting. Let's look up leukemia. Yeah, so he does have this genotype, which two risk factors for leukemia and NQ. But yeah, okay, it's not that big of a deal actually. It's not that big of a deal. This genotype is low risk of leukemia, and this genotype is high risk of leukemia. Yeah, it's not that big of a deal. Yeah, maybe I overreacted. Leukemia risk here is not that high. All right, let's go through the monogenic traits and find out what maybe I missed. So for warrior versus warrior, the sample is definitely much more of a warrior, scoring 56% odds for the warrior phenotype. Based on COMT, MAOA, and MAOB genotypes, this person has got a warrior phenotype. So higher activity of the COMT and MAOA and MAOB enzymes and quicker dopamine reuptake. These enzymes break down dopamine in the system, so you'd have less dopamine because of higher activity of these enzymes, low dopamine levels, and higher stress resiliency in stressful situations. For dopamine Z2 receptor sites in the brain, he's got intermediate or lower number of dopamine Z2 receptor sites in the brain. So actually, well, I don't think it's fair to say that there is lower. I think the percentages wise, it's just intermediate. So intermediate predisposition to such conditions as schizophrenia and bipolar. Pretty interesting. He does not have the A1 variation in TOC1. That's kind of typical. For 5-HT and serotonin, he's got a predisposition to higher levels of 5-HT and serotonin, which is very, very cool. So he's got some protection from depression and anxiety, and I think he scored very low for depression and anxiety. So, well, I don't have an anxiety risk score. Maybe I should add an anxiety risk score to my mental health panel. But he scored very low for depression, and he actually has a long form 5-HT-TLPR. Wow, I think I should put that in the thumbnail that he has long form 5-HT-TLPR. So, 5-HT-TLPR is a gene repeat in the, I think it's called the HTR2A gene region. I don't quote me because it's been a long time since I coded that, but I think it's the HTR2A gene region. Yes, and essentially it's a gene region where you have a repeat, a duplication, or you have a deletion. And people with the repeat, people with the long version, they have it's been clinically proven that they have a significant reduction in the odds of depression and anxiety. And it can be determined from an SNP that's located nearby, whether you have the long version, whether you have the repeat, or you have the deletion. So based on this one SNP, you can determine whether you have long form or it's not even one SNP, it's like two SNPs. But based on these two SNPs, you have determined whether you have the long form version or you have the short form version of 5-HT-TLPR. So this sample looks like they have long form version of 5-HT-TLPR and lower risk of depression, which is really, really cool. And it's also a very European trait to have long form version of 5-HT-TLPR. It's a very European trait to have. So that's really cool. Looks like they have intermediate odds of autism, which is really cool to see as well. No dwarfism. All right. For lactose persistence, they have lower odds of lactose intolerance, which is really interesting as well. So they have all these genotypes for European lactose persistence. They have heterozygous in this variation of MCM6. They have two variants for European lactose persistence in this variation of MCM6 as well. And they have heterozygous genotype in this variation of LCT. So they have plenty of variants for European lactose persistence. If we count those together, it's 2 here, 1 here, and 1 here. So it's 4 out of 8 variants in total for lactose persistence. And that's why they score 60.3% for lower odds of lactose intolerance. So they are definitely lactose persistent. Well, not definitely. There's still like a slight chance that there might be lactose intolerant, right? So my trait predictor looks at that and it still gives them a 3.7% chance of lactose intolerance. It's gotta do that because it's gotta be nuanced. It's gotta take into account this nuance that there's still people who are lactose intolerant sometimes. But most likely they are lactose persistent. And for empathy, they're scoring higher level of empathy based on these 1, 2, 3, 4, 5 S&Ps. All right. For diabetes, they're scoring. Well, I'm not gonna look at that. It's too complicated. Um, all right. For Alzheimer's, no risk factors for Alzheimer's and APOE. They score below average for Alzheimer's, so that's based. Cardiovascular issues, actually, for multiple sclerosis, no risk factors for multiple sclerosis in HLA, which is really good. And they also score below average for multiple sclerosis, which is really good as well. Cardiovascular issues, they score intermediate or higher odds of cardiovascular issues. So we remember they were scoring higher for the cardiovascular disease panel on the polygenic risk scores, which is very unfortunate. And for facial morphology panel, actually for vitiligo panel, let's go over that as well. They have heterozygous genotype in these two HLA variants, so that's quite unfortunate. And by the way, they are different genes because this one is HLA-A and this one is HLA-DRB1. I just noticed that. So these are actually different genes that are both implicated in vitiligo, that are both in HLA, which is very interesting. Did I put them both in different locations? Did I put them in different locations? I need to investigate that. I might have made a mistake if I put them both in HLA-D. I need to investigate that for sure. So they've got European genotype in all the variations of EDAR. Oh, I think I messed up. I think I put the HLA-A02. I think I put this one in HLA-D. I need to investigate that right now. I think I just found a bug in my own application. I'm gonna investigate that right now in a couple seconds, in a couple minutes. All right. They got higher odds of protruding nasal bridge. They got smaller nose size. They got slightly thinner eyebrows, and they got lower odds of missing teeth. All right. They don't have micropenis. They don't got. They got one fat gene variance in this variation of FTO. All right. And they're not an Asian flusher. Okay. We're gonna skip that. They don't have any risk for pain hypersensitivity. Let's see. What can we talk about here? What can we talk about here? They don't have any albino variants. They're not albino. They actually do have a variant for familiar Mediterranean fever. So they have a risk variant for familiar Mediterranean fever, which is a condition that affects Mediterraneans mostly. For MTHFR panel, they have some genotypes that predispose them to if predispose them to higher homocysteine levels, such as this one, for example. This leads to lower efficiency in processing folic acids and higher homocysteine levels. But this other genotype right here leads to normal homocysteine levels. So overall, probably the result for homocysteine panel is going to be quite good. For the cancers panel, they're scoring intermediate odds of epithelial cancers. And this is based on 8q24 region. So there's actually not that many genotypes here because it's not a very high quality file. It's 1, 2, 3, 4, 5, 6, 7 genotypes. But based on these genotypes, the result is that they have intermediate odds of epithelial cancers, which really means slightly higher than average. Intermediate here in this context means slightly higher than average odds, which is kind of bad. And that takes into account epithelial cancers is like basically any kind of cancer that's not blood cancer. So that's pretty much testicular, breast, prostate, brain cancer. It's any kind of cancer that's not blood cancer. It's most cancers that are epithelial cancers. For rare diseases and traits cancer, they got what else do they have here? They have high risk of rheumatoid arthritis, but already went over that. High risk of ankylosing spondylitis, aspirin-induced asthma, and eosinophilic esophagitis. But that's pretty much it. All right. They have single HLA-DQ8 haplotype, which leads to high risk of celiac disease than average. So that's one HLA-DQ8 haplotype that's risk haplotype for celiac disease. Very interesting. All right, and I have two protective variants in HLA-C, which leads to 90% reduction in HIV viral load. Very, very interesting. For HLA gene panel, they're scoring intermediate odds of, which really means slightly higher odds of autoimmune disease. But now we're gonna find out. Did I make a mistake with the HLA-A genotype for the? I think I did. I think I made a mistake here. Yeah, I made the mistake here. Oh, this is so bad. I put this in. This is HLA-A, and I put this into HLA-D. I shouldn't have done that. So yeah, this goes into HLA-A, and I put this into HLA-D. So next update, I'm gonna have to fix that. I'm gonna have to remember this little mistake, and I'm gonna have to fix this. I'm gonna have to put this into HLA-A because this is a HLA-A gene. I'm gonna have to put this here. Wow, it's a good thing I noticed this now. Yeah, because that's a big mistake. It's good I noticed this now. All right, it's gonna eat me for the next couple of days. All right, so for the CBS panel and homocystinuria panel, they're scoring intermediate or elevated levels of homocysteine. That's interesting. Why is that? The MTHFR panel the result was quite good, but okay, that's why. So they got all these three genotypes in the CBS panel that are leading to elevated homocysteine panels, elevated homocysteine levels. So elevated levels here, elevated levels here, elevated levels here. So that makes sense. These genotypes in CBS panel are leading to elevated homocysteine levels, and they also have one risk gradient for homocystinuria and a homocysteine level and a homocystinuria panel. So because of that, despite the MTHFR result being quite good, they're scoring 30% for elevated homocysteine levels. That makes sense. That makes a lot of sense. So when you take that into account, the results of the homocysteine panel and the cardiovascular panel, because of that, the result for cardiovascular issues panel on the polygenic risk score page was quite bad. It was 1.3 or something, I think. One point. Let's check it now. Let's check it right now. We can check it right now. Yeah, 1.16. Oh, it wasn't even that bad. It was okay, but it's still above one. It's still higher than one, so it's still a little bit worse than one. Right? It wasn't that bad. Okay, so for muscular dystrophy myopathies, it looks like no risk variance for any muscular dystrophy myopathies, and no risk variance for ADL. For color blindness panel, one risk variant and OPN1 is W. That's okay. Might be a miscall. I'm not sure. For FTO gene panel, predisposition, some slight predisposition to obesity, which is very interesting. So 35% odds for higher odds of obesity, 45% odds for intermediate odds of obesity. So really intermediate predisposition to obesity, but there is some slight predisposition to higher odds of obesity as well. That is because they have in FTO they have this genotype which is homozygous for fat gene, and then they have these two other genotypes that are heterozygous for fat gene variants. And then in other genes, in FK, PFKP, they have genotype for lower BMI, and then other genes they have some other genotypes that are perhaps implicated in obesity as well. So really, it's kind of a mixed genotype. They have some predisposition to obesity, but really, it's kind of hard to determine. For syncope panel, based on 3 SNPs, they have a predisposition against syncope actually, lower than average predisposition to syncope. Pretty good to see. So a little bit protected from syncope. And for biotraits panel, it looks like they have one copy of the hunter-gatherer gene variant and one copy of the farmer COTCL1 gene variant, which is to intermediate ability to process carbs and sugars. Very, very interesting to see that. They have wet earwax, normal or smell air body odor, and normal colostrum, which is typical for non-East Asians. Very, very interesting. I was very surprised when I read that because I was like, "What? East Asians have East Asians have non-smelly body odor? East Asians don't smell? I never know that." And for blood group panel, looks like they have a blood type that is kind of hard to determine. Let's zoom in. So it's kind of difficult. This is one of those cases where my trait predictor has a hard time determining the blood type. It might be type B. It's at 50% likelihood. It might be type A, which is at 29% likelihood, or it might be type O, which is at 20.7% likelihood. But it is not type AB. Thank you guys for watching my video until the end. Make sure you check out the description of this video. In the description of the video, you can find a lot of really cool things. You can find the link to download the actual sample, the Celtic DNA file that I analyzed in this video. You will have to buy it. I do sell these samples now. Earlier in my YouTube channel, whatever endeavor, I would just give them for free, but now I sell them. That is because It takes effort, and I don't make much money, so I try to find avenues to make a little bit of money with what I do here. And it is good to, you can support me a little bit. It doesn't cost much. It's only like $1. So you could buy it for $1 and support me in what I do. Good deed. But there's also links to buy my Trait Predictor, which is the tool that I use to generate these reports, and it will work for your own DNA file. You can generate reports for yourself, for your friends, for your family, for your buddies or whatever. And it will work with MyHeritage, 23andMe, Ancestry, any microarray sequence format DNA file it will work on. And also, you will find just a lot of really cool things in the description. So make sure you check out the description of the video. Thanks for watching my video, and leave a like and subscribe if you enjoyed it. And goodbye.